All right, let's do our final property of logarithms here. Now this one has to do with exponents. And this property is the multiplication to exponent or the exponent to multiplication property. Another great thing about logarithms is logarithms turn exponents into multiplication because multiplication is easier to do than exponents. And so logarithms are awesome, okay? So let's say we have, this one's actually really easy to understand. Let's say that we have 4 times log base 5 of 2. So you can see here that we only have one logarithm, and then that logarithm is being multiplied by 4. Well, whenever you multiply a logarithm by anything else, this multiplier can actually go into the logarithm and become an exponent, not on the logarithm. It doesn't become an exponent on the logarithm, it becomes an exponent on the argument inside of the logarithm. So this becomes log base 5 of 2 to the 4th power. Not the logarithm to the 4th power, but the 2 to the 4th power. So if we have 6 times the natural log of x, this 6 would go on to the x inside the logarithm, and it would become the natural log of x to the 6th power. And then what if we had x times log base 7 of 13? What could we turn this into? Well, think about it for a second. Why don't you try it? All right, so this x, because it's a multiplier of the logarithm, would go inside of the logarithm and become an exponent. And so this would become log base 7 of 13 to the x power. And now the inside of this is now an exponential expression because it has a variable in the exponent. All right, so now let's reverse it. Now let's go from the exponent to multiplication. What if I have log base 9 of 5 to the 3rd power? Well, if we have an exponent inside of the logarithm, we can take that exponent off of the number inside the logarithm, and we can put it on the outside as multiplication. So the 3 would go in front of the logarithm multiplied by the logarithm. So this would become 3 times log base 9 of 5. All right, good. So what if we had the natural log of 15 to the 4th power? Well, 15 to the 4th power, that's a really big number, right? I don't want to deal with that big number. So in order to not deal with a big number, I'm going to take that exponent off of the 15 and move it in front of the logarithm. And I'm going to make it 4 times the natural log of 15. Now the natural log of 15, that's much simpler. And then all we do is take that answer and multiply it by 4. And that would give us the same answer as the natural log of 15 to the 4th power. In fact, maybe you're not sure if that's true. Maybe that sounds outlandish to you. Well, let's try it. Let's find out what natural log of 15, oops, that's 7, 15 to the power of 4 is. You see this is the natural log of 15 to the 4th power. We'll press enter, and we get 10.8322. All right, well, let's just do the natural log of 15 all by itself, and then press enter. And now let's multiply that number, 2.7, and multiply that by 4. And let's see what we get. We get 10.8322, the same number, okay? So we can see that moving the exponent in front of the logarithm as multiplication, that this works out, okay? We've just seen that inductively. All right, so now let's say that we have the natural log of 1.05 to the x power. And so what we would do is we could take the x off of here and we could move it in front of the logarithm, and it becomes x times the natural log of 1.05. And now I want to show you something. This property is the property that we're using when we use logarithms to cancel an exponential base. You've seen this already, right? We've had like 1.097 to the 12x power, right, is equal to, I don't know, is equal to 4, right? And what I have said to you is the way you cancel this exponential base is by doing log base 1.097 on both sides. Log base 1.097 on both sides. Well, let's not cancel it. Let's do this. Let's rewrite it. This is now log base 1.097 of 1.097 to the 12x power is equal to log base 1.097 of 4. Now, based on this property, what should happen to this exponent? Can't we take this exponent and move it to the front? And now we would have 12x times log base 1.097 of 1.097 is equal to log base 1.097 of 4. And then what is log base 1.097 of 1.097? It's 1. It cancels. And now we have 12x is equal to log base 1.097 of 4. Okay? And that's now hopefully you can understand why when we're solving exponential equations, we just cross this out and bring down the 12x. It's because really we're shortcutting moving the exponent in front of the log. That's what we're doing. You're just shortcutting it. But it still works. It still turns out the same answer. So you keep doing it this way. You just keep working out the exponential equations by doing a logarithm and crossing it out, okay? Because that's how it works, okay? All right, that's it for this third property of logarithm. I've got one more video to show you where we have some fun with the properties of logarithms.